Hello, good morning. Today we will talk about marine ecosystems and how their resilience can be enhanced through INREM. So throughout history, mankind has been pushing, controlling, and trying to master the elements. And for the longest time, that was beneficial to us. But of late, we can already see that the drivers of development, such as land and sea use change, direct exploitation, and climate change and pollution has actually led to declines in nature. We see already that there is a 47% decline in natural ecosystems. We already see 25% of species already threatened and um, with possible extinction. We already we also see decline by 23% on average of biotic integrity uh, on terrestrial communities. We see that the biomass and species abundance is actually fallen by 82%. And nature for indigenous communities, or the elements of nature that are important to indigenous communities, have actually um, decreased by 72%. So it is no longer possible to continue this way without looking at the climate change. As we have witnessed the occurrence of extreme events, these, these can easily wipe out years of infrastructure investment. Shown here is a picture of Andoy, when it passed in 2009, and the consequence of that, just a half a meter rainfall within a few hours um, already resulted in a lot of fatalities and a lot of damages. And if you take a closer look at the picture, you will see that it's not just water that damaged it. No, there were a lot of mud. This is because there's the interaction of the precipitation event and at the same time the land use, on the on the highlands near the cities. It resulted in a lot of erosion and a lot of mud actually ending up on the streets and inside houses and inside cars. Another such event was in Yolanda when it passed through the Philippines in 2013. It was a Category 5 storm with huge amount of fatality and a lot of damages. And as you can see here in the picture, two pictures on your left, there this was Tacloban before Yolanda and after, a few days after, and you can see, it basically wiped out that area with only very few structures left standing after the storm surge. And yet we also see that there were areas that um, could have been more damaged because of the storm surge of Haiyan, and yet they were able to survive. Shown here in this picture is Palumpon, and offshore of Palumpon to your upper right, you see a mangrove plantation, located a few hundred meters offshore. And this actually helped buffer the full impact of the 3.6-meter storm surge that still occurred in the island, but with much, much less intensity. So whereas the picture before showed even big buildings, being erased by the storm surge, here we see that um, even uh, even the more flimsy structures, with your regular yarrow or your regular tin roof, all of this still remain. And this is not the only area that was spared because of mangroves. In other places, also in other storm events, there are several barangays that reported that they were spared because their particular barangay had a lot of mangroves. So these are Barangay Pariñam, General MacArthur, and Old and New Busuang Clan. So we see that nature can actually help protect us. So simply put, well, when you do not take care of the environment, we suffer, and when you do invest in nature, we benefit. This feedback response has become obvious from the terrestrial point of view and should be incorporated in all our developmental planning. To bring this message across to the next generation, my laboratory, in collaboration with a gaming company, actually came up with a tabletop game called Resilience, Survive, and Thrive. And with this, you see the interaction between nature, development, and climate change. You know? So I encourage all of you to try and find the game and play it in your classrooms, in your workshops, so that the next generation will be able to see the interaction between these three without having to experience it like we did in Andoy and Milan. Um, but that's looking at it from a more terrestrial point of view. But from a marine perspective, marine protected areas are investments as well. You know? So it's not just the roads and the buildings and the infrastructure that you see on top of land, but it's also the areas that we decide to protect near the coast. These are vital for our health, for our well-being, and these are usually uh, put in place to benefit mankind, no? Mostly for fisheries and biodiversity, but you can. It's also has enhanced tourism, for example, carbon sequestration, and the result uh, is you can see that the even though this is also costly, the economic benefits are quite high. No, there's a 3 to 1 to 20 to 1 economic benefit ratio if you do this correctly. And equally so, we have to protect this investment so that they will benefit generations to come. Because if we don't, extreme events can also wipe them out. This is the picture depicted here is that of Apo Island Marine Park, which unfortunately suffered two um, typhoons. Sendong came in 2011 with a wind speed of 19.5 kilometers per hour. Pablo came in at 2012, another Category 5 storm. And the coral damage is 99% uh, after these two storms. So there was hardly any coral reef standing. And the coral reef related fish also declined by 50%. So this is devastating because this Apo Island is one of the um, really successful marine protected areas, not just in the Philippines, but globally. No, and for 3 decades, it was run very well, and it increased the reef fish abundance in the area so much that other areas look at Apo Island Marine Park as a great example. And yet, even after 3 decades of protection, two extreme events wiped it out. So it's very important, therefore, to take into consideration climate change. So when Apple Island was established, you only had uh, very few storms passing through that area, and most of them were tropical depressions and tropical storms, so very low energy. Um, and but now, no, in 2000s and 2010s, and now in 2020s, we see that the strengths of the storms that pass through have actually increased. So the total number of typhoons and tropical storms have not changed, but the intensity has changed. And this was not taken into consideration when the park was being developed. Naturally so, because it wasn't occurring. So why do you need to take that into consideration? But now that we know that the highest probability scenario is that we will keep getting bigger and bigger storms, then you have to take a look at where you would place your marine protected areas. Also, placement is very important. Now we have realized that windward, no, those areas that are facing the typical direction of incoming storm is very dangerous, and likely to be hit by a big storm in the decades to come. So there is now a drive, an impetus to actually start developing protected areas on the leeward side of islands or behind um, the islands, so that these are naturally more protected for the most part, and therefore investments will not come to waste. No? Um, and then aside from storms, there are other climate change um, parameters that you need to take into consideration. No? So if you take a look at our habitats, no, coral reefs are known to be very, very sensitive to increases in ocean temperature. And uh, there has been observations of bleaching events that happen during prolonged high temperature events. No? And if this continues on, if it doesn't dissipate, it can lead to coral death, no? And eventually macroalgae will take over. Similarly, coral reefs are also very sensitive to ocean acidification because it's calcifying. So an increase in ocean acidification will actually damage uh, the structure of the reef. No? So either one would actually result in loss of cover, which would typically also mean that the smaller bodied coral associated fish that are dependent on the structure will also be affected. So only a very few types of fish will remain. And those that will remain are generally not utilized as food fish. If you take a look at seagrass are also very sensitive to storms, because they can be uprooted with the increased energy of incoming waves. But they're also highly stressed if the area suffers from high sedimentation. So if you couple bigger storms or high rainfall events to land use that is prone to erosion, then you have the potential of damaging both your corals and seagrass due to this sedimentation. Sea level rise can also lead to loss of deep water seagrass habitats that are at the edge of their limits due to light availability. And the combined effect of murky water, storms, and sea level rise can actually lead to the thinning of meadows and a decrease in seagrass species diversity. Storms and storm surges were also shown to defoliate and damage mangrove stands. No, so we saw this in Tacloban. Old tall mangroves that are taller than the average tree line are the ones that are most likely to suffer. And then mangroves are also very sensitive to your sea level, no, because um, mortality can ensue as a substrate deepens beyond depths of capable of supporting vegetation. If it's just for a short period of time, um, some of these species can tolerate uh, increase in salinity due to sea level rise, increase in salinity of the ground due to sea level rise, but prolonged exposure can actually impact the biodiversity of your mangroves, no? Because it will thin out those that are not as tolerant to high salinity and also thin out those that will be inundated. If there's no, if nothing impedes their growth, they will naturally adapt to for the next generation to be in a higher level, farther away from the increasing sea level. But if there is structure behind your more landward zone, for example, if you put roads there, if you put infrastructure like malls or promenades and so on, that will not allow for this natural adaptation, then you end up thinning your mangroves, both in biodiversity and also biomass. So if you take a look at all that, so ocean acidification, warming, uh, increase in sediment because of bigger storms, and also unusually high rainfall, and then also sea level rise, you see how all of these can affect the integrity of both your coastal habitats, your corals, your seagrass, your mangrove, as well as your coastal integrity. So we therefore need to take a look at how these are projected to change with the passing of time. So one way is to find models, but the global models only have very few pixels for the Philippines. We do have some attempts for local models, but not in the resolution that is needed for adaptation implementation. So instead, we take a look at historical data. And if you take a look at historical data of temperature, sea surface height, and precipitation, using mostly satellite-derived data, then we see that the Philippines naturally clusters into 11 different um, climate change typology. Uh, some areas, like those facing the Pacific, for example, will have been historically um, experiencing higher than usual of extreme heating events, increases in ocean temperature, extreme rainfall events, disturbed water budget, and sea level rise. Disturbed water budget means you already expect it to be a dry season, yet it's still raining, or you expect it to be a rainy season and yet it's still dry. But some areas are only have only been prone to extreme changes in sea level rise, for example, like the inner Sulu Sea. So it depends where you are. Historically, it the area has experienced different things. No? So, for example, if you belong to the Tacloban area, then you've been experiencing extreme heating events, increase in ocean temperature, extreme rainfall events, and sea level rise. So these are the parameters that you need to take into consideration now when you are doing your marine MPA planning. So if you overlay the climate hazard clusters that we showed you in the slide before, and the coastal and marine habitat distribution, in this picture on the left, it's only for coral cover and mangrove cover. But if you overlay that, then you will see which regions um, will be affected by what type of climate hazard, and therefore which coastal habitat will most likely suffer. So for example, in ARMM, which has been experiencing unusually high sea level rise, compared to global average, then you project that the mangroves there will be the ones to suffer. So therefore, you need to take into consideration how you would protect those mangroves. And if you're going to do reforestation, you will most likely need to put that in the more landward side, since sea level is already affecting those that are near the water. Okay? So in this way, you know where to concentrate your efforts. Um, and so that's number one. No? So you have to start including climate in the design of your marine protected area. Number two is that you have to create multi-habitat species. No? We've seen in coastal communities that they benefit from the presence of mangroves. Equally, MPAs are shown to be more resilient if they encompass more than just one habitat. No? There are several studies that have shown that areas with all three habitats, corals, mangroves, and seagrass, actually have higher fish diversity and higher fish biomass. So overall, they maintain a high biodiversity if all of them are present. But in the Philippines, we mostly protect one type of habitat. No? So in some areas, it's just the mangroves. In some areas, it's just the coral. So what we're pushing for now is uh, to actually take a look at the presence of all three, no, in order to prioritize areas of protection. No? So this is the framework we're pushing for, um, and uh, we propose that going forward, areas like these which have all three habitats are prioritized. So our next speaker after me, Dr. Likwanan, will probably deal more about that. The third thing that we need to take into consideration in order to increase the resilience of our marine protected areas is the natural relationship between different sites. No, coral and fish larvae can be brought to far distances by ocean currents. There are things called source reefs, which are able to provide larvae for export to suitable growing sites, and these are then imported by sinks, no, where the propagules eventually end up. Some sites are self-seeding, and which only means that it depends on the local supply, and these are therefore very sensitive because once damaged, it's hard for them to grow back again. And as you can see in this picture, the monsoon season is very influential in terms of where the sources and sinks are in different times of the year. So different species have different spawning frequency, and therefore there might be an influence of where uh, specific species actually come from and are related to. No? So protection is critical for these habitats. If you look at it at a more fine scale, you'll see that um, other areas in the Philippines um, are also connected, no? Not just necessarily by monsoon season. So as you can see um, in this circulation, the dominant currents in the Philippines link very far areas, no? So sometimes you see that larva that is released in the Tawi-Tawi region, for example, reach all the way to Palawan. Those released in the West Philippine Sea side of Palawan reach all the way to the Calayan Island groups. And then those released in the like Mindanao area actually end up or not just in the Philippines but even further south to Indonesia. So and this again, this changes also with the monsoon season and the strength of the North Equatorial current. And this should be the basis, one of the basis informing your network of management and protection. An example of this is you can see here the heat map of the offshore reefs of the Calayan Island groups. And as you can see, it has a wide impact, a very large scale. It actually influences not just the coastal areas that face the West Philippine Sea, but the other parts of the coral triangle as well. No? So corals and fish larvae of the Calayan Island group are sourced for neighboring islands and reef systems. So the protection of the KIG benefits not just the Philippines, but the rest of the coral triangle. Another example is this connection that is identified within the West Luzon network, no? All the way from Batangas and Cavite to northern Ilocos. And the other one is in the VIP Sibuyan network of region. And the boxes here, the red and yellow box indicate the broad-scale networks of sources and sinks in this area. The fourth thing we need to take into consideration are the pressures that are actually coming from the terrestrial side. No? So shown here in this illustration is the connectivity of the coastal areas due to current flow. But equally, there's also connectivity between the highlands to the coast. Um, there's delivery of sediments and nutrients towards the coastal area, coming from the different land use of the nearby highlands and coastal area. No? So, and then these do not necessarily just stay locally. If the input is quite high and the currents are quite strong, then these terrestrial inputs can actually be brought to farther areas. No? So this also needs to be mitigated because it will affect the resilience and sustainability of your MPA. Shown here, for example, is an area where you see the sediment outcoming from the different land use of the nearby coast. No? And this is a perennial threat um, to both seagrass and corals because it can make the waters turbid, lessening the productivity of your seagrass. But at the same time, if it's too much, it can actually bury both the seagrass and the nearby coral reef. And so typically we take a look at that land use, land cover, and um, overlay to that the possible precipitation events or storm events that will bring out the sediments to the coast. And we see here in the inlay where Agusan River, Cagayan River, and Mandulog are shown to have sediment blowouts during the passage of storms. So this can affect your nearby coastal areas, coastal habitat. And depicted in pink on the upper left side is all the location of all your coral reefs. So these are the potential impact sites. However, these are not the only sources of sediment for that area. There are three other things that we need to take into consideration. There is mangrove conversion, where areas that are naturally mangrove covered are changed and made into fish ponds for production. But each hectare or square meter of uh, converted mangrove actually reduces the trapping capacity of that area, for sediments incoming from the highlands. So if you multiply that reduced trapping capacity with the number of hectares converted from mangroves to fish ponds, then you can actually calculate the amount in metric tons of sediment that can end up in your coastal habitat, instead of being trapped in your mangroves. So it ends up in seagrass, in the coral reefs, or it gets blown offshore. Okay, so this is one. The other one is the proliferation of coastal structures. So you can see here on the upper left side where I place the flags, uh, coastal structures. So it can either be um, groins or piers or actual reclamation areas, which can actually alter the sediment transport of the area. So instead of the sediments just going from one coastal site to another, it ends up getting blown out, because it's trapped in one area um, where the currents are coming from, and it accumulates there. So the next big storm or rain event, they will actually get transported instead of the natural accumulation near the coast. So if you take a look at the number of structures and the average change in um, square meters of land use near these structures, then you can also calculate the metric tons of sediment that can potentially end up in your seagrass and coral reefs. And these are not small events. So if you take a look at this picture in 2004 and 2015, in 2004, you can see there are not many structures, maybe just a few along the coastal areas. But in 2015, you can already see a lot of protrusions on the coast, and ending up having more sediments accumulated here and therefore higher possibility of transport to these coral reef areas offshore, and a reduction of sediment on the eastern side. No? So it used to be full here, and now you have a lot of erosion. And if you take a look at that specific area shown by the arrow, this is now bare and eroded. This used to have houses. No? So you have a drastic erosion of your coast due to the protrusions of coastal structures in the where the sediments are coming from. So all these sediments ended up offshore instead. And then finally, you have mariculture as another source of sediment. No? For each cage, if the feeds are not applied correctly, no? So if you overfeed, a lot of your fish cages actually have a lot of uneaten feeds at the bottom of these. And you can calculate the amount of kilograms of uneaten feed that end up at the bottom of these cages and calculate for the possibility of that ending near your coral reefs and seagrass, more so because we tend to put our structures very near this coastal habitat. So these are sources of stress. So if you put them all together, this is what we're pushing for. You know? So in order to advance the marine ecosystem resilience and sustainable development of your marine protected areas, you have to include climate change as part of the risk assessment in establishing MPAs. You need to increase biodiversity in MPAs by including multiple habitats in the MPA establishment. You need to consider connectivity as a basis and prioritization and design of your MPA networks. And you have to consider the source of sediment, nitrogen, and phosphorus as part of the mitigating measures for the environment. And these are actually also highlighted in a paper that showed the planetary boundaries of measured. And we can see that the biodiversity loss is actually the one that is observed to be beyond safe planetary boundaries. No? So the second one is actually your increase in your nitrogen inputs. And the third one is your climate crisis. So, and then we also saw that deforestation and other land use changes have high impact on the biodiversity loss as well. So basically we're echoing what is observed to be now beyond safe planetary boundaries. So that's what we're pushing for in terms of integrated development. To put all of these together, with my laboratory also came up with a decision support system. It's called Reef Baby, where we try to incorporate all of this. No? So we have the different habitats, different activities, both upland and near shore, and then climate. And basically to show what needs to be done in order for the system to retain its integrity or even get better. It's mostly a discussion to support system to allow people to experiment without actually having to do them on the ground. No? So experiment, play around with the possibilities of management interventions and see how this will affect your entire system. So if you're interested in this, just contact me and I'll give you a copy of the program and the manual that goes along with it. So that's it. Thank you for listening, and I hope you see that the marine ecosystem protection needs to be approached from different directions. No, it's not a simple thing of just guarding a specific area. That's it. Thank you.